Hello coders, welcome to the new series of my channel. So this is the first episode of the series, which is we are going to call it the scientific programming in Python. So in this first episode we will talk about the random walk, and I will talk about it actually. But the thing is, this video has recorded before, so the quality of this is a little bit of like, the meh. So just watch it, learn, and if you have any questions, comment down below, and don't forget to subscribe. Thank you. Today I'm going to show you how to simulate a random walk, which is a in mathematics it's called like drunkard walk. Damn, that's a weird thing. It's like, imagine some kind of like drunk person that moves randomly, and it can like move in 2D, like these kind of things. Like it starts from some point and it starts to walk in different positions. But at the first, we are going to start with the 1D, like the one-dimensional. It can only go to the x-axis in this axis, and then we're going to start to look at the 2D versions of this. So it's a very simple thing. I'm going to keep it very simple because as like I assume that you are beginners in the Python, so we are trying to keep it very simple and clean also. So first thing that we are going to need, you should open the Colab. If you don't know, you should just write down colab.research.google.com, and then you open a new notebook and you're gonna see something like this. And then you're gonna hit this button here, and you're gonna click on the connect to a hosted runtime. And after you're getting connected, you're good to go, and you are going to be able run your codes through your browser, like Python codes, without needing any installation on your Windows or any OS that you are using. So first of all, I'm going to import a library. Like libraries are a set of tools and functions which are defined in a package that you can use them, and you're going to see how we're going to use. To import these libraries that we're going to need, we should use the import, and we're going to use random because we have randomness in our problem. Then we're gonna need to, in specific part of a library, to show actually how our like random walker is moving in our 1D space. So to do that, I'm gonna say from a library called matplotlib import pipeline. This is the specific part that we need from this library. Also, I can say like name them as something. To do that, to be easier, like I don't want to, every time that I write the code, I don't want to like pipeline. It's kind of a big thing. I just want to say like import it as plt. Even you could do this like this, like rd or anything, but random is enough, I guess. So I'm gonna run this. To do that, you can click here, this play button, or you can do shift enter. So then our libraries are important. So this problem that we are going to solve is kind of a discrete time problem, like at moment 1, 2, 3, 4, 5, 6, 7, 8, such like that. To do that, we need to define a maximum time, that how many time steps that we want to this walker move in different directions in random behavior. So I define something called max time to 100. And also I need to define something that says like where my walker is in this space. So to do that, I need to define some initial position that I put to 0. So in a 1D plane, imagine a 1D line, 0 is in the middle, so it can go backwards or to the forward. It can go advance and like go the backwards. So it's like it can take one step to the right or one step to the left. To do that, I can define a set of these actions that my walker can do. I define something called actions, and I put equal to define a set or list of things we use this, say, here. To do that, I put like it can go like to the one, like one to like +1, let's say, which we don't put the plus here, so only one, and or it can go to the left side, which is -1. So this is all settings of my problem, right? So if I hit shift enter or like clicking the play button, I'm gonna have like these, my rules are defined here for the problem. Now I'm gonna define a loop. Why do we define a loop? What is a loop? Loop is something that you define in coding to do something over and over and over and again until some limit that you put, which here is going to be like our max time, which is equal to 100, right? So to do that, to define a loop, we say like for, let's say t, which stands for time, right? You can like put anything that you want, not numbers, only the words and letters. So for t, in range of max time, I put this sign, 2 dots, and hit enter. And as you can see, it shifts a little bit to this side. This is called indent in the programming. In the next episodes that we are going to go deeper in problems and do much more complex things, I'm gonna tell you. But here I can give you some simple explanation that this indent here stands for like the space and the specific code for this loop that we defined here. Then also this range thing is like, it ranges the number, like it's here, like we defined 100 here, right? Here it ranges from 0 to that number, right? Like it like gives like how many numbers in the range of those between 0 and that number. Now we need to write this. So what do we want? We want this walker, which has a position 0 at the first, to choose a decision randomly, right? So we define a decision and we set it equal to, so it should be random. It should be random choice from these actions, right? So I say random dot choice, right? From what? Randomly choice from what? From these actions, right? I put the actions here. So every time this code, in every instance of time, like every moment until like 100, which is 1, 2, 3, 4, 5, 6, it goes until 100 time, this walker, the drunk person, is going to choose randomly between 1 and -1, right? And then what do you do? What do you want to do? So it decides and then it moves, right? So to do that, we say like position of this walker should be equal, or like we can say like plus equal, right? It means like add your decision to your current position, right? The decision that you made +1, going one step to the right or one step to the left. Add that to your current position. Like imagine at the first time step, it decides to go to the right. So it is gonna add this to the position of itself. and it's going to be 1, this position. So we're going to add the decision to the position. Now we are going to do something. We want to, this is gonna work. Like, it's gonna move in different parts of the space, like that 1D line, and it's gonna stop at some point. But we want to have the history of this like path, and like what it does, like, you know, like where it goes, in which parts, at which time it was, in what point of the space. To do that, we need to keep it, like to keep track of this movement. So we say like we define something like history of points, and we keep it, it's going to be a list because it's going to be different numbers, different points in space. So we keep it empty, and then come here and say at every t, as you can see, I'm writing inside the space or indent for the loop that I've done. So at each time, so let me do something. At the first, it's going to be 0. So I put the 0 here. So it's going to be initial state. Now, I say history, I want to append, like put the current position at that time inside this list, right? So what I'm gonna do is put the position, append, like inject this position, or add this position, something like this, right? It's gonna do the same thing, append it in there. So if I run this by shift enter, or again by pushing this thing, if I print the list of history, I'm gonna see something like this, a list which contains 100 numbers in it, and it shows the path of the the way that this walker walked around. Now I want to show it, I want to visualize it. To do that, I'm going to say, like, I'm going to show it how. Like, I'm going to show the x-axis, like this axis, as time, like each time step, and this axis, the position of the walker. So to do that, I'm going to say PLT, as you can remember, this library I use for visualization. I define it as PLT. I'm going to plot it, right? I'm going to say plot. I'm going to let what you need to like put what you want in the like x-axis. I want my max time, the range of my max time, and also for the y-axis, I want the history of this walker, right? And then I'm gonna simply show the plot that show. No, I'm sorry. It's gonna be PLT. I have defined PLT. So what does it say? It says for like x and y, it's an error. So it says like x and y must have same first dimension. So apparently my range is like 100, but my history is 101. Why? Because of the 0 here, right? So I can just put +1 here for my range to make it better. Like it's gonna be 101 and 101. So the history has like initial state 2, but time is not like that. It starts from 0 and goes to the 99, like 99, but it doesn't have the 100. So you need to put it +1 here to see what happens. So as you can see, our walker starts from the 0 time and 0 position. This is the position we set. It starts from here, goes down, goes up, goes down, goes up, goes down, goes up, and then starts to this is a very random kind of behavior. So if I increase the time, let's say 10 times bigger. I can like run it again. Every time that you want to run, you can change something, you should run everything again to the 100, and you're gonna see something like this, and it's gonna be like more detailed and more resolution because of the more time that it has passed in this kind of stuff. And it goes around, it starts from 0, goes to -10, around -10, and it goes to the 20. So it is a random walk, and you have generated a random walk and its path in one-dimensional space.